Today I'm going to be explaining textbook problem part 2.1a. So today we're going to convolute this signal and we're going to convolute that signal, and we have the formula y 1 of n is equal to x times x of n convolution of y of n. So now we're going to use it through this formula. So now over here, we can also change it up, something like this, that we can also have this equivalent, right? But it's also going to give you the same answer. I feel like in this problem it's going to be a little easier. So we're going to use this. So now let's examine, right? We have this. H of n minus k, h of k. And now let's solve this part. So we're going to have k, when k is equal to -1 all the way to 1, we're going to have x of n minus k times h of k. And now let's solve this out. So we have x of n minus -1, and then h of -1 plus x of n minus 0, h of 0, plus x of n minus 1 times h of 1. So when we simplify this out, this simplifies to x of n plus 2 times h of -1, h of -1 plus this is not plus 2, it's plus 1, n plus 1, plus over here, and we do realize that h of 0 is 0, so that's going to be 0, that goes to 0. We have x of n minus 1, that's h of 1, right? So now what we have over here, h of -1, that's equal to 2, and h of 1, that's equal to 2. So it's going to be something along the lines of this. N plus 1 plus 2x n minus 1. And let's group this together. So n plus 1 plus n minus 1. Now let's examine our x of n signals, right? So what we can do is we can expand this even more. So we can further expand this to this n plus 1, 2 times del n minus del n minus 2. And then over here, right, we still have the n minus 1 part, so we're going to have plus del n minus 1 plus 2 del n minus 2 minus del n minus 4. So now this long function, let's try to simplify this. So now over here we have only one term of this, right? So we're going to keep this. And then over here we only have one term of this, so we're going to keep this. Then however, over here we have this. We have this, right? So we're going to have, until we have -1 terms of this, 2 terms of this, so we're going to have a total of n minus 2 plus so we're going to have this overall function over here. So we're going to have del n plus 1 times 2 del of n plus del of n minus 2 and then plus del n minus 1, and then minus del n minus 4. So now let's simplify this. We have this whole thing, right? We have 2 of this, 4 of this, 2 of this, 2 of this, and 2 of this. Let's plot this out. So over here, this function would be plotted out like this. Over here, this function would be plotted out like this, because and then over here, this function will be plotted out like this. Make this darker. And over here, this function will be plotted out like this. And over here, this function will be plotted out like this. So over here, 2, 4. So this over here would be 2, 4, and then over here, sorry, my mistake. This is 2, and over here we have 2, and over here we have negative 2. So this should be your overall function. Thank you.
Hi, my name is Ravi, and today I will compute and sketch this function. Let us start off by using this formula. Y of n can also be written as the summation from negative infinity to infinity of x of k times h of n minus k. Let's start off by plotting these two functions, x of n. At 0, the magnitude is 1. At 1, the magnitude is 2. And at 3, the magnitude is negative 1. Let's now plot h of n. At negative 1, the magnitude is 2. And at 2, the magnitude is negative 2. Now, let's use this formula for values where h of n is not equal to 0. So, we can write this as x of 0 times h of n minus 0 plus x of 1 times h n minus 1 plus x of 3 times h n minus 3. Now, let's plug in this for h of n, and let's plug in these values for x. X of 0 is 1 times h of n, which is simply that, plus x of 1, which is 2, times h of n minus 1. So you'll be plugging n minus 1 to these. Plugging that into that, you'll just get n minus 2. Plugging that into this, you'll get n minus 3. Plus x of 3, which is negative 1. h of n minus 3 plugging in here will give you n minus 2 minus 2, and plugging n minus 3 in here will give you n minus 5. Let's further simplify this. as you can see, these two can be grouped together. So let's rewrite this function. N plus 1. Now, combining these two, you'll get -4 del n minus 2. And let's rewrite the rest of the function. So this is your out. Now, let's plot this. So at -1, the magnitude is 2. At 2, the magnitude is -4. At 0, the magnitude is 4. At 3, the magnitude is also -4. And at 5, the magnitude is 2. This should be your results.